Vinegar is a naturally brewed product containing acetic acid. It doesn't matter what flavour vinegar, balsamic, white, malt, apple cider, whatever. If it's vinegar, it contains acetic acid, and acetic acid dissolves rust. Now, we're not going to waste much time with a little jar of vinegar and a rusty nut to prove that this works, because unless the universe is broken, it works. The more interesting question is, how does vinegar remove rust? Magic, obviously. No, it's science. Introducing the ingredients. This is acetic acid. 2 carbons, 2 oxygens, and 4 hydrogens. Normally written like this. And this is the formula for rust. 2 ions and 3 oxygens. But let's first look at a simpler reaction. Plain metallic iron, as in the iron in steel. Well, the short answer is that acetic acid does nothing to iron. Don't worry, we're not going too far into this. An atom has a nucleus, and the nucleus consists of neutrons and protons. The number of protons determines what the element is. For example, hydrogen has 1 proton, oxygen 8. That's what this number on the periodic table means. And spinning around the nucleus are electrons. Now, protons are assigned a positive charge. Each proton equals +1. Electrons are negative. Each electron equals -1. So if an atom has the same number of protons and electrons, its charge is 0. But oxygen, for example, typically has 10 electrons, so it would have a charge of -2. Pretty easy. Now, if we look at a compound like acetic acid, the individual charges are going to add up to 0. And if they didn't add up to 0, something would probably be in the process of changing. Acetic acid, iron. 1 iron atom has 26 protons and in its metallic form 26 electrons, so a charge of 0. And as we just saw, acetic acid also a charge of 0. That's why they don't react with each other. They are both perfectly stable as is. But there's another ingredient in vinegar: water. Vinegar consists mostly of water. And something interesting happens when an acid comes into contact with water. This hydrogen hanging out here on the end is going to move to water, because that's what acid does. Now, the hydrogen within the acetic acid compound has a charge of +1. It's 1 proton without an electron. So when it moves, the acetic acid, now called acetate, loses its 0 balance and ends up with a charge of -1. And the water, which is now called hydronium, a charge of +1. This in itself is a complete reaction. This is what is happening in your bottle of vinegar sitting on the bench. And yes, the hydrogen does go back and forth, but at any one moment, about 1% of the acetic acid will be producing a hydronium ion. Now, the positively charged hydronium ion is going to try to get an electron from anywhere it can, because it needs to be in balance. And it so happens that iron doesn't hold its electrons tightly, so the hydronium ion just takes one. And now the attraction that held the hydronium ion together no longer exists, so it breaks apart back into water and a single hydrogen atom. And that hydrogen atom floats off on its own. Well, not really, because 1 hydrogen atom on its own isn't a thing. So to make this whole reaction balance, we need to double up everything except for the iron. Now we have 2 hydrogen atoms, and 2 hydrogen atoms together are hydrogen gas. Note that our iron has given up 2 electrons. It has a +2 charge. This is no longer metallic iron, and iron 2 doesn't exist in isolation. Conveniently, we have 2 acetates, each with a -1 charge. You guessed it, they team up to form ferrous acetate, which is a white salt. You probably don't want to sprinkle it on your steak, but in chemistry terms, it's a salt that remains dissolved in solution. This is the chemical equation as played out on screen, but this is how you'll normally see it written, just showing the difference before and after. That's neat and all, But the title of this video is about rust, or more specifically, ferric oxide or iron 3 oxide. That's common everyday rust. Note the Roman numeral 3. This denotes that the iron within the compound has a charge of +3, and oxygen nearly always has a charge of -2, which makes sense because our compound has an overall charge of 0. Now, for the full reaction to balance, we need 6 acetic acids and 6 waters. We know what happens next. The hydrogens dissociate to water. The hydronium ions then take electrons from rust, and they break apart back into water and hydrogen. And the rust also breaks apart. Now, the +3 iron atoms stay +3. And if you follow the maths, the rust compound gave up 6 electrons. So that should mean that the oxygen atoms now have a charge of 0, and the hydrogens should also be 0. But not really, because in reality the compounds are reforming as they are separating. I point this out because in water, oxygen has an oxidation state of -2 and hydrogen +1, not 0 and 0. Anyway, forget about that, it's not important. The point is that the oxygens and hydrogens combine to form water. This leaves the iron atoms, each with a +3 charge, and they team up with the 6 acetates to form ferric acetate. Ferric acetate is a salt that remains dissolved in solution. In its crystal form it's a brown powder, which is why vinegar turns brown when you remove a lot of rust. This is the chemical equation as demonstrated, and as before, this is how you'll normally see it written. If you're wondering why I haven't noted AQ, which means aqueous, I don't think ferric acetate is soluble in pure water, so noting AQ would be technically incorrect. In our case it's dissolved because it is soluble in vinegar. Anyway, moving on. So to summarise, vinegar removes rust because acetic acid creates hydronium ions in water. Hydronium ions are unbalanced, and the subsequent electron reshuffle results in the iron atoms transferring from a solid state in either steel or rust to a dissolved state as a salt, ferrous or ferric acetate.